So basically, the first thing we're going to do, because I don't think it's done on on those computers yet, is we're going to add sheet metal tab. And it's going to be in the video eventually, but basically what you want to do is you want to go to open, or you want to go to new.
Where's open?
Look on the projector. New, then create a new part, click OK.
Whoa. Oh, okay.
Alright, so it'll open a new part. I already have sheet metal tab here, but basically what you want to do is go up here, click, it's loading. Okay, once it's done, customize. Once you have customized, go down on that list, find sheet metal. Click sheet metal, but don't exit yet. Don't click OK. So what you want to do is you want to, once you click sheet metal, it should pop up right here, but it'll be kind of gray, right? So right click on that and click, what's it called? Oh, it's already added to that one. So on that one you have it. Yeah, show tab. Click show tab, and it'll stay there once you. So now you can click OK, and it should be fine. It should stay there, right? Is it still there? Oh, this is not good. Okay, now, so this is your basic layout, right? So the way SolidWorks works is you have sketch, which is what you start with, right? So any part that you want to do, whether it's sheet metal, whether it's a solid part, you start with a sketch. So if it's a rectangle, you start with a rectangle, and then you can extrude it to make it a 3D shape. If it's a triangle, and then you can do whatever else you want, right? So the basic tab that you want to start with is the sketch tab, right? So in here, let's start a sketch. So basically, go to sketch. And you're going to have an option of 3 planes, and that's just the orientation in 3 dimensions, right? So if you look at something from the top, this should be the top plane, right? So you're looking at it from the top, and this is the front plane. Let's say we're going to create a simple shape for now. Let's do something like a cube, right? So click on the front plane, and it's going to zoom in. Now you have this menu right here, which is a lot of different shapes, right? And you can pick whatever shape you want for this, whatever we're building to be, right? And so let's just create a rectangle that's, so you click one side and then you drag and then release to get the full rectangle. Got it? Okay. So now we need to figure out what dimensions this rectangle is, right? So we go to Smart Dimension, and now you can click on whatever line and then click on the side. And then you can modify that dimension. So let's make this edge 2 inches. Just 2. Click enter. And then do the same thing for the top line. So click on the top line, drag it up, and make it 4. The top one is going to be 4 inches. And then click enter. Okay, so now we have a rectangle that's 2 by 4. Okay, so let's say that for now that our sketch is done, you can go on right here and click the check mark that closes the dimensions, and you can click exit sketch, and so now we're done with that sketch, right? Okay, so now if you click on the features tab, now you can make this sketch 3D, right? So the way you can make it 3D, there's different ways. You can revolve and you can extrude. So basically what revolve does is it takes that sketch and revolves it around a line or a curved line. It can be around anything, right? So you can revolve it around whatever. Extrude is it just stretches it, makes it a 3D shape. So let's try both. Let's do extrude boss base first. So click on that and see how there's an arrow. So that's the direction. You can change the direction here on the left. Yeah. Let's see. Let me close it. So click on the sketch. The sketch is selected, right? I click extrude. I know we can do that. So make sure whatever you're trying to extrude is selected. right? And then here you can pick whatever distance you're going to extrude to. So let's do 1/2 inch. So 0.5, enter. And this is a preview of your future shape, right? And then you can click check mark to get your final shape. So now you have this plate, this 1/2 inch by 2 by 4 rectangle plate. Yeah, so the way to move this around, is you want to center click or click on your scroll bar, and then you can move it around. If you to zoom in and out, it's the scroll bar. Is that what it's called? It's called the scroll bar, right? It's a scroll bar, and then right click gives you all of the kind of options of your previous of the operation that's selected right here. So on the left, you selected boss extrude, that last operation that we did, and so that's what you're gonna get here. That's just the name. Okay, so now let's try revolving this shape around one of the edges. Yeah, so you can't revolve a 3D part. You need to revolve a sketch, right? So what we can do is, so we don't have to create something new, let's just go to boss extrude. So click on that little plus sign on the left, and then you click on this sketch, and then we can try revolve. And let's do, so now we need to pick an axis of revolution, right? So that can be any line. So what we're gonna do is, let's just pick this line, for example. See what it does, and just, doesn't matter, one of the edges, one of the 2-inch edges. Okay, so now we have something. Now we have this weird revolved cylinder with a rectangle in it. Let's just click the check mark. But see, now we have this weird rectangle sticking out of this thing, right? So besides extrude and revolve, there's a way to get rid of material. Okay, so what we're gonna do now is we're gonna create a new sketch. So go to sketch, and we're gonna sketch on that top plane right here, on top of that cylinder thing that we created. Yeah, so one thing you can do is look up here. There's different views. So you can do a top view, and then you can see exactly where the center is. You should be able to see where exactly the center is. That's fine for now. Let's see what happens with that. So what we want to do is, now we're done. Check mark. Click the check mark, and what we're going to do with this sketch is, instead of, yeah, you already exited the sketch. So now what you want to do is you want to do extruded cut. So what that does is it cuts the material away instead of adding material. And so see, now it automatically picks up this, whatever that is, cylinder, right? And let's do, what was it, 2 inches that we had so we're going to cut 2 inches around that circle. So what it should do is it should take that little notch out of our weird shape. And if we click check mark, it was just this little piece was there, right? So what cut means is it just removes all the material within that, whatever shape you put, right? So if it's bigger, it's just going to remove nothing, which is going to be nothing, right?
But then you made a circle that's bigger than that circle.
Yeah, so look, so there's 2 circles, right? So it's going to remove everything that's in between the 2. Yeah, because it takes the volume, or the area between the 2 shapes. So I could put a square in the middle there, and it'll take everything outside the square inside the circle. Yeah. So if we click on the sketch, extrude cut, 2 inches, should get rid of those things. So now we have a semi. There's a lot easier way to create just a cylinder. So now let's take a sketch. But now what we're gonna do is we're gonna.
We set up a circle. Why do we set up a circle?
So yeah, on the left here, if anything, you can hide, right? So this plane is hidden right now. I should be able to unhide it. Oh. Right, so now I have this plane that's showing. So if I right click on this right here, these glasses show this plane. So I can technically, I don't know, this is completely up to you when you're working in CAD. If you like to see the planes just as a reference, you can keep them on all the time. Sometimes when you have like a lot of different things, there's too many planes, so it gets really crowded and it's really hard to see. So you want to hide them.
How do you create a plane?
Okay, so we'll get there, but let's do it right now. So let's say you want to, so you have 3 planes right now, right? Let's say you want to create a plane that's at the bottom of that thing on this circle right here, right? So there's several ways to do it. Let's say way 1, what we're going to do is we're going to click on this surface. Okay, so go to the custom right here. If you want to do 2D planes, go to this options, go to customize, and then yeah, I mean that's fine. You can keep it or delete it. Doesn't matter. So find reference geometry. Click reference geometry, and then go back here again. It should be. Okay. And my window is too small. Okay, hold on. Let me. So it should be in the toolbars on top. I'm gonna move this back to my screen real quick. So, okay, so now you can create any plane you want. So now most of the stuff that we're gonna do in robotics is gonna be sheet metal. So once we get our CNC, we should be able to just make these sheet metal parts, put them into a 2D sketch, and then send it to the machine. The machine should be able to make it out of our 1/4 inch or 1/8 inch aluminum sheet. Right? If it's a complex part. If it's a simple part like a 2x1, then we just need to drill a couple holes and then we can just make sure. Print out a 1-to-1 ratio, glue it on the drill a hole. Yeah. So what we're gonna do is we're gonna go to sheet metal tab. Everybody on the sheet metal tab. Once we're on the sheet metal tab, we're gonna go to base flange /tab.
Flange?
Yeah.
Flange.
Okay, so now we get the three planes again. So let's just create it on the front plane, right? And what we're gonna do is we're gonna let's create a rectangular, same thing that we had before, a rectangular 2x4. So you remember how to do that? That's just regular sketch. So create a rectangle, smart dimension. Let's make it 2. Let's make that 4. Okay, and then we cook that, and we can click exit sketch. So now we have. So now, before you do anything else, once we create this sketch in the sheet metal part, what it's going to do is it's going to ask you for a thickness because this is a sheet metal, so it can't be flat. You can't just have a sketch there. Yeah, so it has to be some kind of sheet, right? And that's where this comes in. Sheet metal parameter. This thickness. Yeah, 0.125. That's what I have right here. And then everything else we can leave the same. So now we have click the check mark. We have a 2x4 inch, 1/8 inch piece of metal. So about this big. Right? Yeah, it's pretty small. So what we're going to do now is let's create. So what you're going to do is you're going to create an edge flange, right? So basically what happens in sheet metal, to create 3-dimensional parts, you're going to bend the metal, right? So if you have a flat sheet, you want to bend ends to make a kind of a box, right? And then you're going to do whatever you want to it. So let's create an edge flange. That's called an edge flange. So right here, edge flange. And then what you're going to do is you're going to pick a corner. So let's say this is the corner. And what's going to happen, it's going to let you drag it the distance of your wall, right? So let's make the 2 inches, 2-inch wall. So type 2 and just click enter. I'll give you 2 inches. You got it too? So you can also change. You can also change the angle, right? So here, yeah, here you can change the angle. Let's say to 45. You can make it 30. You can make it whatever you want. Let's make it 30, or why not? Right? And then we can click the check mark, and we're gonna get this. This is our final product after that bend. Right? So now, let's say we want to do a 90-degree bend on the other side. So we're going to create the same thing, edge flange, click this edge, let's do 2 inches, why not? 2 inches, keep it at 90 degrees, click the green check mark. So this is a piece that we have, a realistic piece that we can make, right? Now let's say, since this is sheet metal, we want to make it lighter, right? So what we're going to do is we're going to create holes inside of it without compromising the structural rigidity or the final shape of the entire part. So what we're going to do is we're going to go to sketch, and we're going to sketch. Let's do it on this surface because this is the biggest surface. So what we're going to do is we're going to create a sketch on that surface.
How do I switch negative?
Yeah. Okay, so click on that surface and let's create a sketch there. And so what we're going to do, let's go to the view and let's view it from the top. No, sorry, not the top. This side, the center view. Look at that one. Back. There you go. Click the back. So go right here and click the back view. So now we can create whatever we want in here. So for
Are we on the inside of it or the outside?
we're on the inside. So you want to go to view and click back. Yeah, so it's fine. It doesn't matter which side you do. So now what we're going to do is we're going to create triangles. Right? So we're going to make a line that goes down. And we're going to make another line that goes 90 degrees sideways. Doesn't matter the distance right now. This is just for demonstration purposes. And then the line that connects them. Then we're going to create a second triangle just a little bit off, just so that we have material there. So another. So here, and here. So now I have 2 triangles. Share with Julian. There's the 2 drills are showing you. Share with Julian. They're not similar triangles, but that's okay. So create a couple of triangles. Yeah, triangles are the only shape that does not deform when if you have hinges on the edges, right?
Basically, think of the bridges you cross, like really big bridges. There are a bunch of triangles connecting them, right? And if you go at the Roman times, instead of triangles, they use domes. Same purpose. Super rigid, distribute the weight.
Okay, so now that we've made these triangles, plus they take up the most space. In a square part, you can put in the most triangles. Circles are going to leave you a lot of space, right? A lot of cut out space. Say again?
When they pick up all the space.
Yeah, but if you put an entire rectangle, your structure is going to be so thin and just going to be able to just move it around and break it. Okay, so now that we can exit sketch, now that we have these triangles, what we can do is we're going to go to features, extruded cut, same thing we did last time, and instead of selecting the whole thing, we're going to select just these triangles. Select all of the 4 triangles, and let's do direction. Direction is fine. And for the distance here, since you're cutting material that's only an 1/8 inch thick, you can do 0.2, and it should be okay. You should be able to cut all of them.
Within like a depression, right?
Say again?
You're making a depression.
We're cutting away material.
Yeah.
Okay, so now you've cut away.
Cutting
Now,
This looks nice.
now we can actually see the weight. So the first robot has a weight limit, right? So if you make everything out of just 1/8" sheet metal, it's going to be pretty heavy without anything cut out of it. So that's why you want to do this. If you look at there should be properties. All right, so when you go to evaluate, if you go to evaluate, go to mass properties.
Like look.
So here you have your part that we created selected, right? And it tells you what the weight is, right? This weight is based on a material, but it's also, remember, it's this big, right? It's 4 inches by 2 inches. So it's just, and we cut out pretty much most of it if you look at it. So it really shouldn't weigh anything. But now let's go back. Let's not, so remember it was 0.05, right? Correct? That was what the weight was, 0.05 pounds. Now we're gonna go back, and before the cut, I mean, you actually can leave the sketch there, that's fine. You can leave the sketch there, and then you can go back to evaluate and go to mass properties. Oh, okay. So we lost 0.2, more than
0.02.
Yeah, 0.02. So more than 20% of the weight, 30% of the weight, because it's 2 out of 0.07, right? That we lost. So that's a significant weight reduction without a major reduction in rigidity because of the triangles. Our part is still not flimsy. We still can't really just bend it anywhere we want, right? Yes. So you can weld or you can make holes, but we're gonna make some holes in here to attach it to something else. So what you want to do is you want to go to sheet metal tab and create simple hole. Right here, simple hole. Put that simple hole on. Say it's here. So see, now you have a sample simple hole here. So it's just a regular hole all the way through the material. So what we're going to do is we're going to make this hole, let's say, quarter 20 is not a hole.
I know.
So a 1/4 inch hole. Let's say we're going to make this a 1/4 inch hole. And that's going to be, since our material thickness is 0.125, that's what our hole is, 125. So that makes a 1/4 inch hole that's 0.125 inches deep. So one thing you can do instead of making the depth manual, you can click link to thickness, and then it'll automatically make the hole whatever the thickness of the material is at that point. And then you can, let's say, check. Now you got a hole in your material. Enough 1/4 inch hole. Okay, so now we have this hole, right? What we're gonna do now is we're gonna create a. So let's say you have very sharp edges, right? You don't want to leave those sharp edges on your material. Whenever you send it to it, let's say it's this box, and you're gonna leave really, really sharp edges on there, so you get cut every time you handle it. No, right? So what you want to do is you want to. There's something called a fillet and a chamfer. So a fillet is a rounded corner, and a chamfer is just a corner that's cut. So whenever you're putting two parts together, you always want to have chamfers on the on where one goes into the other. Let's say you have a screw that goes into a hole that's like closed on the end. You want to make sure you have a chamfer on the screw on the bottom, and then on the hole on the top, so that when you're lining the screw, you don't nick the edges. So let's say you have a hole here, right? If you put the screw in and you like hit this material will kind of bend in here, and then you're never going to be able to fit the screw in anymore. So what happens is if you put two chamfers here and here,
Muhammad, you're going to break.
even if you misalign the screw a little bit when you're putting it in, it'll just slide in, right? And then it'll slide in right in. So okay, so what we're going to do is we're going to create chamfers on all 8 edges of this piece right here. So go to fillet, chamfer, and if you look right here, if you just click on it, it's just going to create a huge chamfer on all of it. And the one thing is, look right here, the chamfers you can change the angle of, and you can change the depth of. Okay, so let's make this a 0.02 because our thickness is 0.125. So let's make a little one right here, right? And so then you can actually click on the other edges and it should add them to all of them. Yeah. So even on, let's say, these corners, you can do it. Right, so if you click check mark, I didn't do all of them, but just for reference, this is what's going to happen. So now it's a very kind of not rounded shape. Safe, yeah, there you go. Very safe shape. Can't cut yourself on it.
Oh yes.
Right, but this also is a lot easier to put things together. If you have something, it's going to be a lot easier to put this into like a slot than it would be when you have sharp edges, because that way, right? You can also make fits closer with this. Right, so what we're going to do is we're going to go to new. Go ahead, Chelsea. New. But instead of clicking part, we're going to click assembly. And click OK. So now you're going to have a new assembly. And see what it says right here on the left? So select a component to insert, then place it in the graphics area or hit OK. So we're going to go to Browse. Yeah, save all your parts. So click OK. I'm going to open two other ones that I created. So now you want to put them on there, right? So put this one, and then you're going to get the second one.
The second one is
Just put it somewhere on there. Just put it right next to it somewhere. It doesn't matter where. What happens if you have two components and both of them are just free floating? Whenever you move something, it's just all going to blow up. It's just going to go all over the place. If you have many components, it makes it even harder because you have 5, let's say, even 5. They can go all different directions and you're just not going to be able to piece them together again, ever. So what we're going to do is we're going to mate them. So basically, we're going to create relationships between the two objects that are going to prevent them from going in certain directions. Okay. So what we're going to do first, the way mate works is it works on surfaces and edges. So what we're going to do is we're going to click mate, and it's going to ask us what to mate with each other. So for now, let's just do the bottom of your, the bottom of that on top of your cylinder. But I'm going to do the bottom of this on top of this piece. So see how it moved it up? And there's different things that you can use to mate. You can do coincident, which means it's touching. You can do parallel, which means it's just you can move it. Look over here. You can move it anywhere, but it just stays parallel. Right? Coincident means it's in the same plane. Perpendicular means it's just going to be perpendicular, and you can move it anywhere as well. So let's do coincident because we want it flat on top of, let's say, our cylinder that you have, or this what I have here. And then we're going to click check. Okay, so now once you click the first check, you're still going to be in the mate screen. Okay, so let's create another one because you can still, even if you're coincident here, you're still going to be able to move it all the way around. Right, so what we're going to need to do is now we're going to need to create another mate that's going to mate the edges so you can't move it. Right, so the edge of this we can mate with an edge with another edge. Right, and that way those edges are always together, so you can only do it this, slide this way or up and down. And then we're going to mate up and down, and then we're going to mate this way. So you need at least three to not move. Right, we're going to do 4 just so that it's perpendicular to this as well. Right.
And if you don't have
Mates can get really complicated.
And you can overmate it and then it doesn't.
Yeah, so if you, well, think about it. It's over constrained, right? So if you, sometimes when you, let's say you made it to this edge, and then you have another part and you made it to this edge, but you move this part. So what is this part going to do? Because it's made it to this part and this part, but this part moved. So it's going to be like, I don't know what to do. Do I expand? Do I like move with this part? Do I stay with this? Like, I have no idea. So it's going to give you an error. Right, so you want to make sure, poor part, right? Yeah, so you want to make sure that your mates are always
There for you.
Sure, you can put it that way. All right, so off of that, let's select this edge right here, or whichever edge you have, and then mate it with this See how that moves? So what happened is now these are coincident, so they're in the same plane as well.
Oh, so we have
Circle.
Yeah, so I'll show you in a second. So then we're gonna make this. Okay.
Ooh.
So now, we have 3 mates now. I'm gonna exit. If we want to move,
It's just one component.
it's just one component. So
Can you unmake these?
see, it says the selected component is fully defined and cannot be moved. That means that we've mated it properly, and they're not overmated. They're just right so that you can't move any of them because they're 3 axis of.
I think the basic. Two.
Yeah, you can make it whatever dimension you want. If you need help, I'm going to be creating it on this screen. So, and once you get to the 2 counterbore holes, don't put them in manually yet. I will show you how to do that using the software.
So we're making that right now.
Yep, we're making that right now.
Wait, what's
Yeah.
so?
What?
Wait.
No, this width.
How you-
Oh.
You mean that?
It's sheet metal, there's a metal.
Yeah.
Are we making out of sheet metal?
You can do regular, regular.
Sketch.
2, 4, and I'll do
6 and 8.
Have you seen it? Have you seen
6 there.
Wait,
So
how
what
big?
do we want?
Oh, do we make a plane basically?
Last team to finish, that's the very turkey.
I'll work with it. Wait, how? Dude, that's so.
Yeah, you're confused because you missed the first. Let him show you how to do this because he was here for the first part.
Yeah.
Oh, we're just gonna, okay. Okay, so we just do the smart touch.
I guess make it front plane on the X. Yeah, that's right. Again, we want or Y. Z. Definitely.
How wide are the anything? I don't wanna make it too big, just in case.
How what? You can make it 2 by 2 by 4 or what. It doesn't matter. Whatever you want. The bottom should be pretty simple. Should be just a rectangle, right? Actually, let me make it a little harder for you guys.
No, it's already hard enough. It's not hard enough.
No, it's fine, it's fine.
Nah, it's not that hard. I'm just gonna put a chamfer on this edge right here.
It's not too bad.
Oh, I thought you were going to like make them cut out a square in the middle of it or something.
Put chamfers on both edges right there. And how big? Yeah, it's up to you guys. Doesn't matter.
Okay, how do you make
Yeah, I know, but
No, you're gonna extrude. Yeah, that. This right here. Like the whole thing, because that's our actual thing, right? The big one. And just do any holes anywhere.
3 holes somewhere.
Okay, just do 3 centimeters. What's our thickness? Here, just cut.
Shit.
Oh, what the? You're done.
Wait, is that hollow or not? Wait,
What? The thing? No, it's not hollow.
That's supposed to be the thing. Oh, the rectangle's hollow. We forgot to do that.
It's not hollow.
The rectangle's not hollow.
The thing at the bottom, right?
No, it's not hollow.
I'm pretty sure.
Nothing is hollow.
Oh,
Okay,
you
yeah.
made it harder on.
I'll decide. The next one will be harder. This one is gonna take like a few minutes. So.
No, you should give him my top.
Think of something. For the next one. Try to make one sheet metal part and one non-sheet metal part, and then you can combine them.
supposed to be in an arc, or does it not matter?
It doesn't matter. Wherever you want them.
It's our thickness would be 2. Yeah, 2 inches. 2. Yeah. Okay. Just do that 2 more times.
So let me. All right. You guys have it open? Okay. So look up on the screen. Basically, if you want to already do pre-made holes, because we have bolts that we use that are already pre-made, right? They're quarter 20s, they're number 10s, and so on. Okay. So what you want to do is go to Hole Wizard, and basically you get a whole different bunch of different types of holes, right? Yeah. So you have different types. You know how you have different screws that are either like socket heads, which are square heads, or you have the ones that are like this. So there's all kinds of things, and you have different counterbores for different types of screws, right? The most common we're going to use is the regular counterbore, right? So what happens is right here under size, you can pick the size of screw that you're going to use. So right here, hole specifications under size, and there are these really tiny ones, number 10s, quarter, so on. So quarter inch, let's say we're going to use quarter inch screws, right? And then here's something else for the fit. So you know how for a Vex the screws go pretty easily through the holes, right? So you can either have the screws go loose fit, which means that they're going to jiggle a little bit, a normal fit, which is going to be kind of like Vex, or a tight fit, or close fit in this case, which is basically that they're going to be really, really, like it's going to be hard to put them in, but once they're in, they're not going to move around. Okay? So, and you can choose, and that's going to determine the actual diameter of the hole. Right, so let's just
do you want something to do like a normal, just nice?
I mean, we can just do, for now we're going to do normal hole, normal fit. Right? So then we're going to click.
Well, time only make like parts that once you make them, you're not gonna touch them at all. Or, like once you make that like parts,
Yeah.
it's not gonna be touched at all.
For example.
And it's started scrolling, and I was like, will it thread it automatically for you if you need it to do that?
This should have a thread function somewhere, yeah.
Oh yeah, we did a lot.
So yeah, so now we have hole position, and we can put, let's say, put it right here, and on the same, so see how this dashed line comes up? That means it's on the same level as that one, so we're going to do that.
Can you make it the same distance away from the edges?
Can.
I need the
So you can go to Smart Dimension, and you can actually click from here to the edge. Let's make it, I don't know, an inch. And then you can click on the other one to the edge, and make this an inch. And they're on the same line, but they might not be the same distance from these two edges, right? From the top and bottom edge. So what we're going to do is we're going to click on this. Because they're on the same horizontal line now, if you just constrain one, let's say an inch, it should constrain both. Or maybe not.
Right.
Just
So
constrain both.
instead of mating, can we just try to use smart dimensions instead?
What do you mean?
No, mating is for two.
Mating is for two surfaces of different parts. This is for the same part, right? So once you have two different parts, you have to mate them together, but this is just for one part. Alright, so once we have all the dimensions, we just click check,
We're making
and
hybrids.
check, and you see it automatically puts nice little chamfers right here, the right distances, and so on. So it's really nice that
That's
it
so lovely.
does it automatically for you. Okay. Oops.
Maybe I need to look the right one. No, I did.
A mate type. Coincidence. Oh, there we go. Okay, we're done. Yay.
You done?
First time.
Nice.
Cool.
Hey, we're first thing done, right?
So you want to make sure you're pressing check in between every one because it's not going to let you. make that piece in real life. Right? You can make stuff in CAD that has these intricate like internal details that you're never going to be able to drill in real life. So whenever you're actually making a part to be made in like at a machine shop or somewhere, you always need to make sure that your design is
Simple.
like relatively simple, yeah, because when you're drilling a hole, think about the person that's actually drilling the hole. They literally go up to a machine that like what we have in the shop. They take this part, they take your drawing and say, okay, that's 2 inches here. I mean, they have things that align it automatically, but 2 inches here, 1 inch here, 1 inch up, drill a hole. So if your hole is like at this angle with this like rotated here, they can do it. They can have to make a contraption, but it's going to be a lot harder for them versus if you just tell them like, place it here, drill a hole here.
How can you not make those bends?
So
If it has fingers,
so
you
this
can.
bend right here, where's my mouse? This bend right here will only be able to be made on a finger
Oh yeah.
break. The break that we're getting is just
Oh, it's not a finger break?
no. So what we're gonna do, what would have to be done is either there's several options, right? You can make this bend on a non what am I trying to say? Non-finger break, but you'd have to
You have to edit it.
like edge somehow, yeah. But basically, try to think of the person that's making it make their life easier. Because if you have something very intricate, it's gonna make it really
I
hard.
thought we had a finger. But
What you want to do is if you actually want to send this to a shop or send it to the machine that's going to make this, right? You can't just send a 3D thing and say, oh yeah,
Oh.
make these bends and I don't know.
Did
The
we
machine
not-
is not going to understand.
Were we supposed to do those things at the top?
The bends?
No, at the top, the like sort of caps.
The bends?
Okay, yeah.
Yes.
Okay, we didn't do that.
Okay, well
so
let's.
you're not finished.
Yeah.
So
So,
the
but
winner
for
is-
now, look at this. So basically, once you're done with this, right? There's something called. Oh, I hate this. It's so small. Unfold or flatten. So this shows a flat pattern, and see how it's dotted lines right here. So these dotted lines are where you're gonna bend the material. So this is what you would send to a laser cutter, plasma cutter, CNC, and it will make these designs, and then you will bend on these dotted lines, and then you can go to File, Export.
Hey, ours you could actually make it. Have a line there, but let's see it again, right? Does it have a line there? So
I think CAD put that in there for you.
And if you look at Save As, there's a lot of different formats to save it as. So they should have something like a DXF or a DWG. DWG is a standard drawing flat pattern for CAD parts. We're going to save it. And look, it's going to ask us for stuff. What do we want? Sheet metal, faces, edges, annotations. We're going to go to sheet metal, just geometry, because we don't know anything. We don't need anything else.
We don't know.
And then we're going to click check. It should give us a flat DXF. So that is what the computer, or the computer that will take these parts to laser cut will take this part and we'll cut all the lines out and give you a final part.
how do you bend it?
So once you get this part, you need to find the lines where you bend. We were going to get a hydraulic brake, and on that hydraulic brake, you're going to put the part in, you're going to bend, or bend at that line.
You can just show them before they tell.